Okay, so with matrix equations, there are two types that we're going to concentrate on. The first one you've already seen, hopefully. Okay, so here we have 4x minus 3a equal to b, and we are solving that guy for x, and then they give us a and b. First, we need to make sure that we can even add, subtract, whatever we need to do with a and b. So let's go ahead and find their order or their dimensions. A has 3 rows by 2 columns, so it's a 3 by 2, and B is the same. So we will be able to add or subtract them, but we will not be able to multiply them. Okay, so if we are looking at our equation that says 4x minus 3a equal to b, let's go ahead and plug in for a and b. So we would have 4x minus 3 times our matrix A, which was 6, -2, -4 down the first column, -3, 2, 5 down column 2, equal to matrix B, which was first column 5, -8, 2, 7, 0, -5. Okay. Let's take this step by step. If you notice, we have the 3 out front of A, our green matrix, which means that we have multiplication by a scalar. Remember, whenever you multiply by a scalar, it's a fancy way of saying that you have a number out front of your matrix. We're going to distribute that scalar all the way through our matrix. Okay. That means that we have 4x. I'm going to carry the minus. I'm just going to distribute the 3. 3 times 6 gets us 18. Moving across the top row. 3 times -3 is -9. 3 times -2 is -6. 3 times 2 gets us 6. 3 times -4 is -12. And 3 times 5 is 15. And that's still equal to the other matrix on the other side. Yeah. Now, if we had 4x minus 7 equal to 9, we would add 7 to both sides, right? So this is just a side reference. Here, instead of subtracting 7, we're subtracting our second matrix. So what we're going to do is add that green matrix to both sides. So we're going to have 4x is equal to the matrix that was already there, which is still matrix B. We haven't touched it. And now instead of subtracting our green matrix, we're going to have plus the green matrix, which was 3 times A. And remember that since these matrices have the same order, we are able to add and subtract. If they did not have the same order, we could not add and subtract. But because they do, we can add and subtract corresponding entries. So just as a reminder, this means that you'd have 5 plus 18 in the top left, 7 plus -9 in the top right, -8 plus -6, second row, first column, 0 plus 6, bottom left will be 2 plus -12, and then -5 plus 15 in the bottom right. Okay. That means we need to do some of the arithmetic here. We get 4x is equal to 23, -2, -14, 6, -10, and 10. Okay. Back to our side reference again. If we had 4x equal to 2, we would solve that by dividing by 4. And that's what we're going to do next to get rid of the 4 attached to the x. Okay. So is this mathematically sound? Are we dividing everything by 4? Technically, no, we don't have division with matrices. We're going to be multiplying by 1/4. But remember, multiplying by 1/4 is dividing by 4 when we're just working with the numbers themselves. So we would have 23/4, which doesn't reduce. -2/4 gets us -1/2. -14/4 reduces to -7/2. 6 divided by 4 reduces to 3/2. And -10 divided by 4 reduces to -5/2, which means 10/4 is +5/2. Okay. And you don't have to do the arithmetic that quick. Remember, you can use a calculator. Do 23 divided by 4, convert back to a fraction. -14 divided by 4, convert back to a fraction.